Okay, in this video I will be going over Bitwise Boolean. And Bitwise Boolean is super easy. Basically, all the 1 is true and all the zeros is false, right? So basically what you're going to do is you're going to turn number into binary, and then or both numbers into binary, or whatever, how many numbers you need to do in binary. And then if you're going to OR them, then it's as if you're going to add them, but when you add them, you're not going to add them, you're actually going to OR them. So if you have 2 1s, then it's going to be a 1. If you have a 1 and a 0, it's going to be a 1. If you have a 0 and a 0, it's going to be a 0. I'll get more into that later. Bitwise Boolean is very, very easy. So, and the order of precedence again is and, the exclusive OR, and then OR. In Bitwise Boolean, instead of seeing the 2 ampersands and the 2 straight lines, it's just going to be one of them, and that's how you know it's going to be Bitwise Boolean. So for example, let's say we had int x equals 7. Wait. Okay. Int x equals 7 and y equals 3. And we're just going to print, this is not how you print stuff, but just because I'm lazy, I'm going to do that, x and y. So basically convert into binary. We know that 7 is 1 off a power of 2, and 3 is 1 off a power of 2. So basically 7 is 1 off 2 cubed, which is 8. So we're going to have 3 1s. And 3 is 1 off 4, which is 2 squared. So we're going to have 2 1s. Or we have 1, 2, 4, and 1 plus 2 plus 4 is 7. 1 plus 2 is 3. So that's how you know how to do it. And that's it, because we're ANDing, both have to be 1 to be true. Right? We have true and true gives you true, true and true gives you true, true and false gives you false. Right? This is a 0. If there's an empty space, just fill it with a 0. And that's your answer. Well, that's not technically your answer. Your answer is actually 3. Why is it 3? We're going to turn it back to base 10. 1 plus 2 is 3. Let's say, again, let's see we had this case, and alpha equals 64, and beta equals 31, and int gamma equals 128, gamma equals alpha and beta, or gamma. I'm going to print gamma. Well, let's notice this. This is 2 to the 6th power, right? Because 2 to the 5th power is 32 times 2, 64. This is 1 off a power of 2. It's 1 off 32, which is 2 to the 5th power minus 1. This is 2 to the 7th power, right? And like knowing that, you can turn the number into binary very easily, instead of having to like list out 1, 2, 4, 8, 16, 32, 64, right? So now it's 2 to the power of 6, so it's going to be 1, and this at least alpha. Well, actually, let's evaluate this. We have alpha and beta or gamma. Which one do you do first? You do and first. So it's alpha and beta. So for alpha, it's going to be 1 followed by 5 zeros. 1, 2, 3, 4, 5. And for beta, it's going to be 5 1s. 1, 2, 3, 4, 5. And we're ANDing that. So false, 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 and false. So alpha and beta give you false. Why? Again, false and true give you false. For and, as long they all have to be true. If one of them is false, it messes up everything. So in this case, all these zeros mess up everything. So now we have 0, 0, 0, 0. Now what is gamma though? Gamma is 128, which is 2 to the 7th power. So it's going to be 0, 0, 0, 0, 0, 1. And we're going to OR them. Right? So false or false is false. False, 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 false. And false or true is true. Remember, as long as one thing's true, the whole thing's true. So for OR, as long as you see a 1, it's going to be true. For false, if you see a 0, it's going to be false. And then that's your answer for gamma now. That's your new gamma. But wait a minute. This was the same thing I got from here. So your answer is going to be 128. Very simple. Let's do another example. Let's say we had int m equals 512, int n equals 128, print m or n. How do you do it? Well, there's a little trick to this. 512 is the power of 2, if you didn't know. This is 2 to the 9th power. It's 8 cubed, so 2 cubed times 2 cubed times 2 cubed is 2 to the 9th power, and 128 is 2 to the 7th power. Because we're ORing them, we're basically, like, because these are power of true, they only have 1, 1, and the rest are zeros. Same thing here, right? And because this is farther than that, we're just gonna add them. 512 plus 128 equals 640. But like, why, Michael? Why? Well, again, okay, let me explain. 2 to the 9th power, so it's 1 followed by 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the 7th, so it's 1, 2, 3, 4, 5, 6. We're ORing them, right? So you see a true, the whole thing's gonna be true. So true here, and the rest are false. So this is 512, this is 128, and we're gonna add them to get a number in base 10, which is 640. So I don't know, like if you're a number person, then you'll get this you can get this question pretty easy. If you're not a number person, by all means just go to binary, do the 1 to 4, 8 system or whatever, and then do your thing basically. And then we'll do one more example, which is pretty cool. And then I'll go over Bitwise NOT. Let me put this here. Okay. So let's we had. Okay. Okay. The question said, what will be the value of x if 36 exclusive or 40 exclusive or x exclusive or 13 will give you the answer of 15? Because we're exclusive, because all of them are exclusive or, we're gonna exclusive or from left to right. Okay, so let's do 36. Let's do our 1, 2, 4, 8 system. 1, 2, 4, 8, 16, 32. To get 36, we have 32 and 4. This is 36. For 40, it's going to be 32 and an 8. This is 40. So, because we're going to exclusive worm, they're both the same, so false, false, true, true, because they're opposites, and false, right? And now we need exclusive or x, but we don't know what x is, right? So this is going to be x. We don't know what that is, but we do know that whatever answer it gives us, we're going to exclusive or the answer to 13. So, but what is 13? 13 is just 8 and 4, which is 12, and a 1, right? Now we need to get our answer at the very end is going to be 15. Whatever we exclusive word that with, right? So again, this exclusive word x is going to give us an answer, and that exclusive word 13 is going to give us 15. So what is 15 in base 10 in binary? Well, 15 is 1 off 16, so it's 2 to the 4th. So 4 ones, this is 15. So now we're going to work backwards. In order to get a 1, this has to be a 0 because they need to be opposites. They need to be opposites, so this has to be true. They need to be opposites, so false and a false. Okay? Now for x, well, we're going to exclusive word that with x, and we're going to get this answer. So for it to be 0, they have to be the same. So 0, there's going to be 0. True, they need to be opposites, 0 and a 1. False, they're going to be the same. False, same. And yep, that's your answer. So your answer is 1110, or in other words, 8 plus 4, which is 12, plus 2, which is 14. So x is 14, and that's your final answer. Now I'm going to go over Bitwise NOT. Which you might see as a little squiggly symbol. Okay, so basically what you do with Bitwise NOT is, well, I mean, first I'm gonna go over the deeper detail, and then I'm just gonna give you the straight trick to do it. Okay, so basically for Bitwise NOT, what you're gonna do is you're gonna convert the number to binary, and then flip each bit. Basically, you're gonna do it once complement. Okay, but you're not gonna do a two's complement, which is at the very end. You're gonna add one. You're not gonna add one at the very end. You're just gonna flip each bit, and that's gonna be your answer. Because you're nodding it, right? If there's a true, you're gonna nod it to a false, and so forth, right? So because we're not adding one, we're technically subtracting one. So like normally in two's complement, we would add one, and we would make our answer negative. So if it was 46 or 54, and then we bitwise NOT it and then add a 1, it's gonna be negative 54, right? But because we're not adding a 1, we're actually subtracting 1, which is negative 55. Let me get into detail on this. So let's say we had int z equals 46. Then we're going to print not, bitwise NOT z. How do you do it? Well, again, first I'm going to convert int 46 into binary. Remember, int has 32 bits, so we have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 0, 1, 0, 1, 1, 1, 0. We're going to NOT it, so we're going to flip each bit. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 0, 1, 0, 0, 0, 1. Right? Normally, again, in two's complement, we would add 1, and that would make our number negative. But because we're not adding 1, we're technically subtracting 1 from two's complement. So our answer is actually, this is 46, this is negative 47. Again, if you were to add 1, it would be negative 46, but because we're subtracting 1, it's going to be negative 47, right? So basically, if you see a bitwise NOT, what you're going to do is you're going to change the sign. So if it's negative, you're going to turn it into positive, or if it's positive, you're going to turn it into negative, and then you're going to subtract 1. So if we had a bitwise NOT 32, you're going to make a negative and subtract 1, negative 33. If it's bitwise NOT negative 45, then you're going to make a negative, which is 45, and subtract 1, you get 44. This bitwise NOT is very easy. Make it negative and then subtract 1. That's it. And yeah, that's it for Bitwise. Yeah.